Hello everyone, welcome to YourPedia Education. So today we are going to discuss the very important topic, that is random variable. If you are going for airport authority exam, right? So basically mostly people think that only probability is important, but random variable is also equally important for airport authority. If you are thinking almost one or two questions are you can expect from probability, and one question or two question you can expect from the random variable, right? So first thing we have to discuss what is a random variable. See, basically when we are talking about the probability, inside the probability the first thing will come into the picture, that is random experiment, right? When we are studied the probability, you should know what is a random experiment, what is a deterministic experiment. So first we have to understand what is random experiment and deterministic experiment. See, when we talk about random experiment means the experiment whose outcome cannot be predicted before doing that experiment, right? Let us take, you are tossing a coin and you can't tell that exactly head will come or tail will come, right? We can predict that maybe head will come, maybe tail will come. With how much probability? That will depend 1/2 for head, 1/2 of tail. So we can say that there is a 50-50 probability, 50% chance of getting head, 50% chance of getting tail, right? So that probability come into the picture for a random experiment. When we are talking about a deterministic experiment, let us take, you are going to your chemistry lab and you mix two compound, right? You mix two chemicals together. You already know, if you are mixing these two chemicals, sodium and chlorine, right, NaCl, then when you combine these two, then it will be form the salt, right, NaCl. So that is the thing we already know. If you combine the sodium with chlorine, you will definitely get the salt. So that is the main thing. In deterministic experiment, you already know that what will be the outcome. You already know. If I mix these two things, I can't even before doing that experiment, I can predict that what will be the output. So that is called a deterministic experiment. So whenever we go for the probability theory, then there is one term that is called as random experiment, right? Inside the random experiment, yeah, we know that what are the possible outcomes. Let us take, you are tossing a coin, you already know that what will be the outcome, either it will head, either it will tail, right? It will depend on that condition, right? It may be head, it may be tail. So there is one thing that is called as sample space S, that is sample space S, right? Sample space S represents what? That is represents the all possible outcomes, right? Let us take, you are tossing a coin, then the sample space will be head, tail. If you are tossing two coins, then your sample space will be, if you are tossing two coins, then your sample space will be head, tail, head, and tail, right? So these are the possible outcomes, right? Now we are going towards the random variable. See, basically what is a random variable? Random variable is a real number which we assign to the sample space. I am again repeating the thing. Random variable x is a real value function, right? Is a real value function from a sample space x to a real number L. Or either you can, in the simple way you can understand that random variable is assigning a number to the sample space, right? We are assigning a number to the sample space, that is the random variable. Okay, so if we are tossing a two coins, then this will our sample space, understood? This is our sample space. Now here I defined a random variable that represents the number of heads. I am defining here a random variable which is define the number of heads. So x is a random variable which is equals to the number of heads. So basically when you toss two coins, the sample space is having this one. So this random variable x having how many values? See, number of heads. The first possibility, there is no head. It means the number of head is 0. So this random variable can take value 0. Number of heads, in this sample space, as you can check, there is a possibility that only one head occur. So that means it will take another value 1. And the last, third case, when you have two heads, right? Two heads means both coin will have two heads, right? Will have two heads. So basically this random variable x can take three values. Either it can take 0, either it can take 1, either it can take 2. Right, rest of the value is not possible there. So this is called as random variable. Right, let us the same thing. You throw two dice, right? You throw two dice and we define the sample space for them if we add the result together, right? Let us take, I throw first die, second die. So what will be the result out? What will be the outcome? We add them together. So we will get the sample space. See, whenever you have a single die, on the single die 1, 2, 3, 4, 5, 6. These are the number are available on single die, right? So if I throw two dice, so what will be the possible outcome when you add the result together? So right. So the sum of two numbers on throwing of two dice is represented by what? XS, that is the sample space that have the minimum value when your first die and second die having 1 1. So the minimum value is 2 and maximum value is 12 when both the die is having 6, and all in between these numbers all be available in your sample space. So this is the sample space for when you throw two dice, right? When you throw two dice and you add together the result, right? So this is your sample space. Understood? Okay, next. Right. So basically the random variable is what? Random variable is a variable which assign the real number to your sample space. Right? Clear everything? Like I give the example, the number of heads. Right? The number of heads represents what? A random variable which take value 0, 1 and 2. Like another, I am representing another random variable, that is x. When you throw two dice, I throw two dice, right? And I add the result together and I tell that this is a random variable. So x is a random variable which is equals to the sum of the result of two dice, right? So we can say it will take how many values? It will take values starting from 12 to starting from 2 to 12. So that is also a random variable. So we can say that random variable is what? To assign a real number to the sample space. So random variables are two types, right? First type of random variable is what? Discrete random variable. Discrete random variable means what? A random variable which take value at a discrete interval of time. Discrete interval of time. Let us take again tossing of coin, right? We are tossing two coins and number of heads will take how many values? 0, 1, 2. This is the discrete values. If I draw that on this x-axis, I will take that value x equals to 0, then 1, then 2. I am not taking any value in between these three values. So that means it is a discrete random variable which is taking value at a discrete interval of time. So that's why we are called this discrete random variable. Generally, tossing of coin, throwing of dice, number of defective items in a bag, these are represents a discrete random variable. Now, next random variable is continuous random variable. Continuous random variable takes all possible value in a given interval or in a given domain. Let us take an example for this one, continuous random variable. I am giving you like I have a random variable which take values between 1 to 2 and it will take all the values between 1 and 2. So this is your continuous random variable. Let us give some practical example for this continuous random variable. See, inside a class, right, there are several students and we are measuring their heights. So let us take the minimum height is 5 feet and the maximum height is 6 feet. So that is the range. Between 5 feet to 6 feet, there is any height is possible inside the class. So what we can say, that is a random variable which will take any value between 5 and 6. Understood? So that means it is a continuous random variable. Another thing, you are measuring a temperature you are measuring the temperature of a room from 12 p.m. to 1 p.m. right, 12 p.m. to 1 p.m. that is also a random variable, and that is in continuous in nature. Means you can measure the temperature which is fluctuating, which is changing. You can't predict that value, it will be changed, it will be sometime increase, decrease, like that. So we can say that is also a continuous random variable. Measuring a temperature, measuring a height, weight of students in the class, that is also a random variable. So this is in continuous in nature, and another one is random in nature. Random variable which is not random, discrete in nature. The random variable which is discrete in nature, that are tossing of coins, throwing of dice, number of defective items in the bag, that are the example of that one. And if we talk about the continuous random variable, that is height, weight and measuring of temperature in a room, right, that are the continuous random variable. Okay, now after doing this, so we understand what is a random variable. Now what we have to do, we have to find one thing that is called as, for a random variable we generally define one term that is called as probability density function, right. In case of discrete random variable, that is defined as PMF. In case of continuous random variable, that is defined as PDF. So there are two things, one is PMF, another one is PDF. PMF and PDF. So remember the name. Sometime in the exam they may ask you that what is PMF? Probability mass function. This PMF represents probability mass function. The second thing is PDF. PDF represents probability density function. So basically we generally define these two terms. So before moving to these two terms, we have to understand one more term that is called as probability distribution. Generally we call that CDF, cumulative distribution function, CDF, right. Sometime it is generally denoted by distribution, probability distribution function. So basically if you have a X random variable, if you have a X random variable, then the CDF, cumulative distribution function of this random variable X, can be defined as f of X, and it will always equals to probability that X is less than equals to X. So this is your PDF. We will CDF. We will understand it better now with the examples. So what the CDF do? CDF add all the probability till where you are standing, right. Let us take an example. Let us take, we are tossing a coin, not a coin, we are tossing two coins, right. So when we are tossing two coins, our sample space is what? The sample space has values head, tail, head, then tail. These are the values of the sample space, right. So when we have these values inside the sample space, now we defined a random variable X that is representing the number of head. So when X represents the number of heads, so X will take how many values? X will take 0 value, 1 value and 2 value. What is the probability of Xi? What is the probability that X will take these different values? See, basically when we have 0 head means which case? 0 head means only this case. So in the favor of 0 head, there is only one element inside your sample space, and total number of elements are 4. Now one head will carry by these two cases, so we can say this one is 2 by 4, and two heads has only this case, so we can say that will be 1 by 4. So we already calculated these probabilities, right, having 0 head, 1 head and 2 head. Now what we can say that what we can say that if I calculate the CDF f of x, right, f of x of x, if I calculate, that will be the PDF probability that x is taking all the values less than x. Now I am going to draw this, try to understand here. So it will add all the probabilities, it will add all the probabilities, it will add all the probabilities which is less than x. Okay, let us take this x value is less than 0. This x-axis, this is your x-axis, right? On this x-axis we are taking the value which are less than 0. So if less than 0, there will be no probability. So it means that will represent the 0 until the 0. So as I reach at 0, with the value of x, then there is an addition of 1/4 probability. So it means at 0 its probability is going to be, its value is going to be 1/4. When I reaches to 1, then there is again a addition of 2/4. So when we add 2/4 with this one, that is become 3/4. So it is doing one thing, it is adding all the probability which is coming out previously, right? It is adding all them. Now as I reaches to 2, what is happen? At reaches to 2, then we are getting 1/4 add here. So that means it will become 1. So from this data, what we understand, that what will the CDF do? Density distribution function, what distribution function will do? Distribution function will add all the probability at which you are calculating the value. Okay, so it is having several properties. The first property of this CDF is f of x of minus infinity is how much? If I calculate the value of this CDF function at minus infinity, that will going to be 0, because there is no probability at minus infinity. If I calculate the probability that x at infinity, so as I reaches to infinity, I will cover all the probability. Always remember, if I add all these probability, that is always become 1. So what we can say, the probability that x equals to infinity, that is going to be 1. One more thing, these are the important point, right? Note it down. This is first point, this is our second point, that probability, the value of the CDF function, the value of the CDF cumulative density function, distribution function at infinity is going to be 1. Next thing, see, if it is adding all the previous probability, it is always increasing function, because it is adding previous values, it never going to be decreased, because the probability is always greater than 0 or less than 1. You remember that thing, the probability is always greater than 0 or less than 1. It never going to be negative, right? Probability will never going to be negative. So if we are adding something from the probability, it means we are adding positive values. So if you are adding positive values, so it means what? Your CDF f of x of x is always increasing function, always increasing function. That is important point about this one, right? CDF is always increasing function. One more thing, if I try to find the probability between 2 points x1 and x2, if I want to find the probability between x1 and x2, you can directly calculate from a given CDF, that will be f of x of x2 minus f of x of x1. So what we can say, there are several property of this CDF. Everyone understood this thing, that what is a CDF? CDF is a function which add all the probability. If I write it, it will if I draw the CDF, that will be look like this one, right? We are adding all the probability which are less than to that value, right? That is the CDF. Okay, yeah, already discussed these things, right? That is, yeah, this is the distribution function, cumulative distribution function, that is fxi, which is adding all the probability until x, right? Okay, let's move to the next topic. Yeah, these are the probability of cumulative distribution function. We already discussed these things, right? Now right, okay, the one more thing we have to understand here before moving to this one. The CDF we already discussed here. Now the thing that is called as PMF, because we are dealing with a discrete random variable, the another thing is PMF. See, basically PMF means what? Probability mass function. Again, I am taking the case of the random variable which is having two heads, that will take value 1 and 2. So basically, if I draw a table for this one, x at x equals to 0, at x equals to 0, it will take p of xi. See, this p of xi represents the PMF, probability mass function of a discrete random variable, right? And this p of xi is going to be 1 by 2, oh sorry, 1 by 4. At 1, that will be 1 by 2. At 2, it will again 1 by 4. So this is called as PMF, probability mass function. Understood? Okay. So if we go that this is a PMF, probability mass function, see, from this data we can understand one thing. If I add all the probability of a PMF, if I add all the probability, means I is equals to minus infinite to infinite. I am taking all the probabilities, right? P of xi, that is always going to be 1. So if you add all the probability, that is the probability of, that is the property of PMF. If you add all the probabilities, right? If you add all the probabilities, that means that is going to be equals to 1, right? If I calculate the probability that x is lying between x1 and x3, these 2 points, then I have to integrate I is equals to 1 to 3, only 1 to 3, and I have to add all that probabilities between 1 and 3 like this. So that will be calculated from the PMF. This is the probability of, this is the property of PMF. So this is the basic idea of PMF. PMF represents was how your probability is distributed amongst each value of the random variable. This is like x is the random variable which is taking the value 0 with the probability 1 by 4, right? That will represented by PMF, and x will take the value 1 with probability 1 by 2, x will take the value 2 with probability 1 by 4. So these are the PMF, right? These values represents, this combined table represents the PMF. This function represents the PMF function. So basically, when we are talking about the discrete random variable, that represents the PMF. If we talk about the continuous random variable, then it will represents the PDF. Now, one more thing, remember, whenever you have a discrete random variable and you are calculating the mean of that random variable, the mean of random variable, discrete random variable, that will be summation I is equals to 1 to n xi p of xi. That is represents the mean of this random variable, right? So yeah, that is called as mean of this random variable. There is another thing that is called as expectations. Expectation of any discrete random variable e of x, that will be given by what? Summation I is equals to 1 to n, right? All the values xi p of xi. So mean represents what the mean and the expectation value both are same, right? The mean and the expectation value are same for a discrete random variable. So generally if he is asking for mean or expectation value, you have to calculate the same value. So that is all about the discrete random variable which you have to know, right? Yeah, one more thing, there is a property of expectation. The first property of expectation is that E of x is always equals to mean, right? I already discussed this thing. One more thing, if you have E of k times x, k is a constant, x is a random variable, then we can take k out and it can be represented by E of x. Means you can take this k outside, here is k, right? That is missing. The k is multiplied by this random variable x, so you can take that k out from the expectation, right? One more thing, if you are calculating the if you are calculating the expectation of a constant value k, that is always equals to the constant value k. And if I calculate the expectation of x plus k, that means we can say it will be expectation of x plus expectation of k. So expectation of k is how much? That is going to be k. So it is E of x plus k. E of x plus k. Again, if I put it E ax plus b, right, like this. So we can say that a is coming out, Ex plus minus b. So these are the properties of the expectation, right? If you are calculating the expectation, sometime he give you the value of E of x and he will ask you that you have a new random variable z that is equals to 2x plus 3, and he will ask you that what will be the expectation value of z. So you can directly use this property. Let us take an example. Let us take, we have a random variable z that is 2x plus 3, right? And it is given to you that the mean of mu of x is 3. He is asking that what will be the mean of z. What will be the mean of z? So what we can say that E of z is how much? E of z is going to be twice E of x plus 3, that is x naught alpha, right? So we can say twice E of x is how much? That is 3 plus 3, so it's going to be 6 plus 3, 9. So we can directly calculate the mean of z by using the property of the expectation. So remember these properties are important about the expectation. Now another thing is variance. See, whenever we are talking about the expectation, so there are two things. Expectation, first expectation means E of x, that is called as mean. E of x square, that is called as second moment. That is called E of x represents first moment, this is represents second moment. That will be given by what? Summation I is equals to, let's take I is equals to 1 to n, right? I am taking only for the fixed sample points, right? That is going to be x square p of xi, x square p of xi. So this is representing second moment, right? So basically when we are calculating the variance is equals to what? E of x square second moment minus E of x ka whole square. So that is your variance of a discrete random variable. So first, to calculate the variance you have to calculate the mean, and when you got the mean you have to calculate the second moment. Second moment means what? E of x square summation x square p of xi. And from this data, if you know that mean and the second moment, from this data you can directly calculate the variance, right? Okay, so that is all about the mean and variance of a discrete random variable. From the variance, that will be the formula for the variance, right? This is called second moment, e of x square minus e of x का whole square, right? When you calculate the variance, there is another term that is called as standard deviation. Standard deviation is under root of variance of x. Standard deviation means what? Under root of variance. So this type of question may be framed from this one. So you can focus on this part. This is important. Definitely one or two question you will get from this part, right? And further parts we will discuss that one, right? That is the property of variance. Yeah, let us discuss this thing. This is also important, property of variance. Similarly, the property of the mean or expectation, we have property of variance. First property of variance, if you calculate the variance of a constant value that is not a random variable, the variance will be always 0, right? C is a constant. If you have, you know that variance of a random variable x, that will be sigma x, or let us take variance not like that, 1 second. Yeah, we have to calculate the variance of a random variable, that is k times x. K times x, like previously, if you know that e of k times x is going to be k out e of x. Similarly, if we have variance of kx, that can be calculated k square. This time k square is outside and we will left with variance of x. So that will be the variance of kx, right? That is going to be k square v of x. Now, if we have variance of x plus k, we have to calculate the variance of x plus k. K is a constant, so what we can say, that is going to be variance of x and the k variance is 0. So that is directly equals to variance of x. Similarly, if we are calculating the variance of this one, variance of ax plus minus b, that is going to be a square v of x, right? That is going to be a square v of x. Let us take an example. Let us take you have a random variable x whose variance is 5, and let us define another random variable, that is 2x plus minus 3, not plus minus, let us take 2x plus 3. This is the random variable, and I am asking that what will be the variance of this random variable z, right? So if you are calculating the variance of this random variable z, that will be variance of z is going to be twice square variance of x, because this variance is going to be 0. So we can directly put it 4 times 5. So this is going to be 20. So sometime this type of question he may ask you, that if the variance of x random variable is given, he will ask you that what will be the variance of another random variable z, which is following this relation for the x, right? So I think I discussed these things, right? Okay, so that's it for this discrete random variable. I think you understand everything from this one, what is a random variable, how we will deal with a discrete random variable, right? We will not going in depth of continuous random variable, and we will deal it later on, right? First try to understand what is the discrete random variable, right? I already told you what is a random variable, what is a random experiment, right? What is a random variable, then two types of random variable, discrete random variable, continuous random variable. After that we will go through the probability distribution function, then we will go through the PMF, then we will go through the mean and variance, right? All of the data I already discussed here. So hopefully this will help you in your AA Airport Authority exam. Thank you.